Hello, my name is Tom Preston, and thank you, Grant, for that introduction there. I am going to be taking you through a technical demonstration of the 2500 MJP printer. So just to begin with, I'm going to just say that this is a really brilliant machine. I'm going to take you through the pre-steps of setting up a print, taking you through setting off a print at the printer, seeing the printer work, and then taking you through the post-processing and the different methodologies of post-processing of the 3D printed parts. So the software that we use to slice our models is called 3D Sprint. It's a exclusive software by 3D Systems for all of their plastic printers. It's a really powerful software which allows us to do a number of different processes with our parts as such. So we can import our native STEP or IGES files, our native CAD, convert that to a mesh body, apply repair tools to fix geometric problems as such, place it into a build envelope, auto-place and orientate our parts for maximum efficiency, create support structures, and send to the printer. So a quick introduction into the workflow. So we have a part here, part geometry that we're going to look at. We're going to add this to the printer. You can now see the print envelope of the 2500 here. So it's a small carabiner part that we're just looking at, kind of maximizing the efficiency of this build as such. So what we're going to do is actually create a fill of the build automatically using the fill pattern tool, which allows us to copy the part and fill the build envelope. We can obviously stack in X and Y, but also Z, which is really nice. You can see here that we have 3 channels that we work with within the 2500. So each one of the channels is shown by the dotted line here. We can see that basically filling the channels up is how the printer is working. So it actually has a head which is only about 8 centimeters long, but we have 3 lots of 8 centimeters that we're running along with the print head. So I'm just adding this now to the queue for the printer. I'm just going to add this now. So just seeing it sending to the printer now. So this is a very basic introduction. I'm just going to move on to something a little bit more complex, which allows us to see some of the more interesting features that the Sprint software enables us for. So again, I'm just importing a part here. It's a jig fixture for a mold. We're just going to do some simple measurement tools here, so I can see the measurement of a part using the measurement tools. I can transform the geometry using the transform tools, so I can scale, rotate, move very simply and easily. You can see that the measurement is updated with that scaling as well, which is really nice. We can do auto placement, which allows us to auto place our part for maximum speed of building. I'm just going to hide the distance there. So this way I can then move on to something a little bit interesting about the 2500 is the ability to create lattice structures within our geometry. So the lattice structure works by creating a shelled object. So right now I'm creating a 2mm shell of the object, which means that now I've got 2 kind of structures in the build. So you can see on the part list here that I've got the first bit and then the internal volume which has been created. So now once I've got the internal volume, I can actually create a lattice structure within there. So by creating the lattice, I can create different styles of lattice. You can see how it's kind of highlighting the internal core in a red color. So there's a number of different lattice structures that we can create. So jack, star, or a 3D grid as such. Or I can create it as a solid or as an auto support, so just creating it as a wax support structure. I can see the lattice structure being generated in the bottom corner as such, but it's only procedurally generated. All the lattice generation is done on the machine, which is quite nice. So this is only telling the printer what we want for the lattice to be made as such. And we can see here that I can manipulate the cell size and thickness of the elements so that I can change the fill ratio of the part, which actually improves the cost of this part without reducing the strength of it, which is really nice. So I can just do a quick now adding some vent drains. So I could leave the wax inside the part, or I could remove it using these vent drains. So again, it's a really nice tool for adding small holes in the part which connects the internal volume to the outside. So simply kind of clicking on the part here, I can add vent drains throughout the part where the wax can come out from the internal structure. So again, so how this mechanism works is it has the part material being created as well as a wax support structure. The wax support is actually generated everywhere it can possibly be generated, in the fact that we are creating like a 2D shadow effect on our part. In this way, we have perfect generation of our parts through the print, and we can just melt that support wax off after the build, which we'll come on to in a short while. So again, just creating an estimate here of the use of material and the print time as such. So 6 hours, 28 minutes. I can see the estimated use of material and wax supports. Okay, so the 2500 is really easy to set off. Simple interface, easy, intuitive. So even through the 3D Sprint, we send down to the printer, which then we have the small LCD screen, which we set the print off from. The machine is really easy to set up and can be printing within the same day of delivery. So this is adding the material into the printer. So we have a 2-slot system so that we can add material throughout the print, so we can continue printing even if we're low on materials. In that way, we never run out of material during the print. Simply setting off the print is click of a button and it's ready to go. So in the print, we can see the part being laid down and the head moving back and forth, quite a fast-paced process as such, so it's been sped up quite a bit. It's moving the head back and forward in the XY position, and then that bed is dropping down in the Z, allowing us to layer on top of the parts. So you can see this was a 4-hour print, very, very quick process of creating these parts. So once we have the print finished, the print bed actually comes out of the build as well. So it's attached with the wax onto the build. And this way we can actually just swap out a build plate and continue printing, which is really nice for throughput on this machine. Once we have the build plate off, how do we get the parts off? There is a hot plate or a fridge method of doing this. A hot plate will heat the bed, which is a steel structure, and melt the wax so that they can be pulled off. And a fridge freezer will contract the wax and actually just pop off from the build plate. So both methods are really effective for taking the parts off of the build. Once we have the parts off the build, we now have to remove the support wax. Now, the go-to method of removing the support wax is the Easy Clean method, which is a steam bath tool, which has a steam bath and a oil bath. So there's 2 components with this. The steam bath removes the bulk of the wax, and then we move to the oil bath, which uses the Easy Rinse solution, a cornstarch oil-based fluid which removes the surface wax from the parts. The solution is held at 65 degrees C to remove all of the surface wax. So once the parts have been cleaned in Easy Clean, we need to then remove the oil from the parts, which we use a simple warm soapy water and wipe the parts. We get really, really nice results with this. So the carabiner is the part that we're showing off here. So using this methodology, we get the full kind of carabiner movement, and it's really, really nice because of all the assembled part there, which is really good. Another method to remove the support wax is using an ultrasonic tank. So an ultrasonic tank, again, is a one-step cleaning process, which is quite nice. In fact, we can drop our parts into the ultrasonic and it will remove all of the parts, even the surface wax. So we use isopropanol and a mineral oil as a mix in the solution to remove all of the support wax. And it also removes all of the entrapped support wax as the ultrasonic movements kind of get into the final to reach areas. The other method is using an oven. So this is good for batch processing. So we can put lots of parts into an oven, melt all the wax off, and then take them out, wipe them off the surface wax. And this is really good for bulk removal of support wax. So for big parts that have lots of wax, an oven is a really good solution. So just having a look at some of the examples here, we can see the differences between the ultrasonic oven and EasyClean. They all look very, very similar in finish, as they all do a very similar job. So this is the part that you'll be getting sent to you. This is an example of an assembly part. It's got a moving element, it's got a flexing part. It's a really, really cool part to show off this detail and also capabilities. It's also got entrapped wax. You can see the 3D Systems logo and the Project 2500 label there, which shows that you can actually have entrapped stuff for labeling and whatnot. So just to have a quick look at some of the stats for printing off this carabiner clip. So a quantity of 1, so printing it 1 on the 2500 in the GCL material takes approximately 1 hour 55 minutes. Material cost is £6.76, and the time per part is 1 hour 55 minutes. So this is a very quick print, nevertheless, but we can start to improve by increasing the quantity of the time per part. So if we look at doing a set of 5 parts, so again, same material, print time is still 1 hour 55 minutes because of the channel system on the 2500, where we are able to fit the whole channel full of parts and still continue with the same time. So the material cost is £21.36. So reducing cost per part, and the time per part is 23 minutes. So again, the reduction in time is massive. So let's fill the build up in the XY. So we can see the print time is now 4 hours 23 minutes because we're using the 3 channels. The material cost is £6.10. But now the time per part is 17 minutes. So we've reduced the time per part massively again. So let's see how far we can push this. So now we fill the Z as well. So we've filled the XY and now the Z. By maximizing that kind of throughput, we're getting 12 minutes per part. So it's a maximum throughput on this as such.